Wonderful. So we are focusing on mitochondrial health, optimizing cellular energy for longevity. So I'm a paid advisor for Pure Encapsulations, and I thank Pure for supporting this event tonight. And I'll be talking about the difference between lifespan and healthspan, mitochondrial dysfunction, nutritional and lifestyle strategies to optimize the mitochondria, cellular health, and longevity. And when we talk about evidence-based approaches, I'm very excited to be able to share the final results from our healthy aging study to show that we do have some evidence that we can slow down aging and improve more of those healthy years for longevity. So when we talk about health span, and in this case here, looking at this image, we can see health span is shown at 71 years. So for example, this person has had 71 years of life in good health. But lifespan or life expectancy is really that total time that someone is living. So there can be this health gap, basically. So life expectancy, the total time that you are from birth to death, whereas health span is specifically those years that you are healthy. And in this example here, which is quite similar to what we see in Australia, most Australians live until their early 80s. However, we do have a health gap of about 12 years, meaning that for over a decade, most people are living with a chronic illness or even more than one chronic illness or a disability that's impacting their day-to-day functions and needing some kind of support. So in Australia and Hong Kong and some of the other countries, we have a relatively long life expectancy into our 80s, but the United Nations reports the world as a whole, on average, the lifespan is about 73, health span 64, and the world's average health gap is about 9 years. So most people living for a decade with a chronic illness or a disability, impacting their quality of life. And in the Philippines, your life expectancy is more similar to those reports from the United Nations. So early 70s is that life expectancy. However, when we talk about health span, which is generally represented as HALE, if you are looking through the statistical analysis from the government organisations, HALE refers to health adjusted life expectancy. So as functional medicine doctors, we tend to talk about health span, but it's HALE when we're talking to the government organisations. And the latest data that I could find was from 2021. And this states that the health span, so years lived in full health without significant disability, disease, or morbidity, was estimated to be just over 60 for females, and a little bit lower for males. So the health gap is about 11 to 12 years, similar to us in Australia, but we tend to be living a decade longer. So we're getting to closer to 70, then having that 70 to 80 with health complications, whereas in the Philippines, it looks like on average, people are really only getting to about 60, which is quite young, before they're starting to suffer with certain symptoms and age-related conditions. The other point I want to make, and this is not unique to the Philippines, this is across the globe. We see this from statistics through the US, Australia, the UK. What we can see for the Philippines, this last point here, is that over time, the HALE, so that health adjusted life expectancy, has declined. So in 2000, the health adjusted life expectancy was 61.2. And then in 2021, which is where this data is from, when we combine males and females, it's 58.8. So it means there is 2.4 years less of those healthy years. So even though in the Philippines you're living a little bit longer as time goes on, you're not having those healthy years. You're living a little bit longer, but those years are with a chronic illness or a disability. And as I said, this is not unique to the Philippines. We are seeing this across the globe. People are living longer, but they are having more years dealing with these age-related conditions and chronic illness. And this is basically what we do as functional medicine practitioners, trying to get people well, so that it's not necessarily living longer, but having more of those healthy years, shortening that health gap. So when it comes to shortening that health gap and giving us more healthy years, we do understand at a cellular level, a molecular level, the things that influence our rate of aging. So some people will age faster and some people will age slower. And this comes down to a number of molecular mechanisms, including genomic stability or instability. And when we talk about genomic instability, really we are talking about here DNA damage. And this can occur from exposures to chemicals and toxins. So that can damage our DNA. We can have spontaneous mutations. So as the DNA is replicating, as we age, things just sometimes don't work so well. Those replication machinery in the cells aren't functioning as well. Things are happening slower, and we start to get a buildup of DNA damage as we age. Oops. Did I just go the wrong way? There are dysfunctional telomeres. So telomeres are things, little caps that sit at the end of the chromosome, protecting that DNA, very important for DNA replication. And as the telomeres are affected, I can see lots of people all coming in. That's great. Sorry, I'm getting all these notifications that people are entering the room. With the dysfunctional telomeres, once the telomeres get short, then the DNA can't replicate. So why do we want the DNA to replicate? We want our DNA to replicate so that we can have new cells. So to heal, regenerate, and grow, we want to get rid of those damaged cells, and we want to have our DNA be replicated. We want our cells to divide, and we want to have new healthy cells. Epigenetic alterations are also a big factor when it comes to aging. So we have this extra layer of information, these methyl groups that sit on top of the DNA that influence our DNA or our genes being turned off and on. So epigenetics don't influence the genetic code, the DNA, but influence gene expression. And when it comes to methylation, we do know a lot about changes in methylation that accelerate or slow down aging. There's also proteostatic stress and, of course, mitochondrial dysfunction that I'll talk a lot more about on the coming slides. But ultimately, all of these things can impact DNA damage, impact cellular health, and ultimately we start to get a buildup of cellular senescence. So when we think of what is happening as we age, we are getting more and more of these senescent cells building up. So what should happen if a cell is damaged because there's been a virus or an exposure to a chemical or a toxin, or there has been a spontaneous mutation in the DNA, or even the mitochondria is no longer functioning as well? These things should be cleared away. We have this apoptosis, programmed cell death, and that will then clear that cell. The body says, you're damaged, I'm getting rid of you. But as we age and the body is not functioning so well, we get this dysfunction. Rather than cells being cleared and having this apoptosis, programmed cell death, we get a buildup of these senescent cells. So they're no longer functioning. They are damaged. We have a buildup of these damaged cells that aren't doing their job, not producing all those proteins, not supporting the tissues and the organs. They are building up and also releasing compounds, often inflammatory and toxic compounds that can damage the cells around them. And that's really what is happening in aging. We're getting these cells that are no longer functioning and causing damage. But we also have changes in signaling mechanisms, a buildup of inflammation, and dysregulated nutrient sensing. But there's a lot we can do that can influence these processes. And we'll talk about this, one from my study, but also no doubt most of you as functional medicine doctors are doing a lot of the things that will protect our DNA, support healthy methylation patterns, support our mitochondria. But understanding this at a molecular level and having tests to now look at biological aging helps us understand what particular supplements, nutrients, and lifestyle factors are actually working. So when it comes to the mitochondria and the mitochondrial theory of aging, and really the last 10 years has been an explosion of interest in the mitochondria. So 20 years ago, I started out in the DNA damage space, and we know that as more and more DNA damage builds up, that does cause that cell dysfunction, increases risk of all age-related conditions, cancers, neurological conditions, chronic illnesses. But it seems to be that the mitochondria, it's the same thing. As dysfunctional mitochondria build up, there is a strong association with not just age-related conditions, but also a lot of the signs and symptoms of aging, fatigue, skin aging, all of that. So what is the mitochondria doing? The mitochondria is making ATP, adenine triphosphate, and this is our energy currency for nearly all of the cellular reactions. And often we think about energy like our muscles, we're exercising, but we need that energy for our DNA to replicate, for that cell to divide, for that repair, for the healing, just to deal with normal metabolic processes from turning our food into energy. So this ATP is so important for energy metabolism. With the mitochondria, though, as it's making this ATP, it's actually the organelle that produces the most free radicals, these reactive oxygen species. So as we're using oxygen to make ATP, we get a buildup of these free radicals. And when the mitochondria isn't functioning well, we can get a buildup of these free radicals, and that can cause cellular damage, DNA damage. So it can actually start to cause damage and accelerate aging. There's impaired biogenesis, mitochondrial DNA damage as well. So we've mentioned DNA damage a few times. So as I said, that's the space I started working in. We know a lot about it. But it's not just DNA damage from what's in our cells that we inherit from our mum and dad. Our mitochondria has its own DNA that we just inherit from the maternal line. And if there is mitochondrial DNA damage, that can then be passed on as these mitochondria replicate. And similar to when I was talking about the buildup of senescent cells, we can get a buildup of these dysfunctional mitochondria. We're not getting that mitophagy. So damaged mitochondria, and it can happen, there can be DNA damage or too many free radicals causing damage inside the mitochondria. It should then be cleared away. But when we age and things are starting to dysfunction, we get a buildup of these dysfunctional mitochondria, a buildup of these senescent cells. And that's when there starts to be this breakdown of our ability to function physically, mentally, and really the hallmarks of aging. So when it comes to the mitochondria and where they are located, as I said, these are an organelle in the cell, important for making ATP for nearly all of our cellular metabolic reactions. But we do have a much higher density of mitochondria in tissues that have a high energy requirement, no surprise. So not just our skeletal muscle, and obviously if there is mitochondrial dysfunction, there's weakness, fatigue, myopathy. The brain also requires a lot of energy, and ATP and any mitochondrial dysfunction can influence brain function and has been associated with a number of conditions, including Parkinson's. The heart, so the heart obviously beating all the time, needing lots of energy. There's a high amount of mitochondria, as well as the eye. And what's not listed here actually is the oocyte. Actually, the oocyte, the egg, has one of the highest densities of mitochondria. So no surprise, the mitochondria is referred to as the powerhouse of the cell. It is the place where the energy, that ATP, is made. So it's responsible for producing the energy needed for nearly all of the cellular functions in our body and our brain. As we age, mitochondrial function tends to decline, contributing to the symptoms associated with aging, including fatigue. So if someone's experienced persistent and unexplained exhaustion, there could be a mitochondrial issue. Exercise intolerance, so difficulty sustaining physical activity or not recovering from that exercise. Muscle weakness is definitely something that's influenced by mitochondria. Pain and cramping as well. Cognitive decline, as I mentioned, so many mitochondria in the brain. So when we're not getting that ATP to fuel all of the actions going on in the brain, there can be memory issues, brain fog, and difficulty concentrating, as well as age-related brain conditions. Metabolic changes, as well as cardiovascular symptoms, irregular heartbeat, and heart disorders have been linked with mitochondrial dysfunction. And there's a lot of research when it comes to the mitochondria with cardiovascular health. And actually, I've been doing a lot of talks on mitochondria and is trying to select which slides to have. I haven't included it, but if people are interested in the research, I can send it through. I have a slide that I've been sharing recently, which just shows the absolute increase in the last decade of studies, research studies that have been published with the mitochondria. And when we talk about the mitochondria as a treatment, I'm going to talk to you from a functional medicine perspective, diet, exercise, supplements, but they're actually doing studies at the moment where they're looking at using the mitochondria to treat things like Parkinson's. So actually mitochondrial medicine, where they're trying to replace the mitochondria in certain tissues. So lots of interesting research going on. But before we get to that point of trying to add in the mitochondria to a person who's dealing with a chronic illness or an age-related condition, there's so much we can do to support our mitochondria. And it's crucial for healthy aging. So what you can see here is a simplified kind of diagram schematic of the mitochondrial electron transport chain. So what you can see over here on the left, complex 1, in this first step, you can see that NADH is important. So this is niacin. There's also CoQ10, FAD, so riboflavin. So FAD is from riboflavin. So NAD and FAD are cofactors for so many enzymes. So it's not just the ATP, we're also getting these important cofactors. So we need to be ensuring that our patients have got plenty of B vitamins to support the electron transport chain, but also our CoQ10. So in this diagram, it actually shows CoQ10 at both steps. But at complex 1, this is what we call CoQ10, ubiquinone, the oxidized form, whereas actually here at step 2, this is ubiquinol, the reduced form. So often we use the word CoQ10, but there is 2 forms of CoQ10, ubiquinone and ubiquinol. So to explain that a little further, we have ubiquinone. As I said, this is that oxidized form, and it's still useful in that first step. And this can be converted into ubiquinol. So there are enzymes that do that. So for those of you who do some DNA testing, you will know that I do this. There is a particular gene called quinone reductase, shown as NQO1. If you've done DNA testing, you can check your results. If you've inherited the variant, even the heterozygote has a big impact. But if you've inherited both variants, which is rare, it's usually about less than 10% of the population, but some people do have a double variant, what we call homozygote. Both mum and dad have given them the variant, and that quinone reductase has minimal enzyme activity. Some studies suggest actually none, others about 4% enzyme activity, but it's a significant genetic variation. Sometimes when we talk about SNPs, there might be a 20% reduction in the enzyme activity, but in this case, it really is having a big effect. So people that have NQO1 are not using that enzyme or the variant, they're not able to convert that ubiquinone to ubiquinol. I do want to make it clear though, NQO1 is not the only enzyme that converts ubiquinone to ubiquinol. So there are other ways of doing it, but some people, this will be compromised. So the ubiquinol is the reduced form. This is the antioxidant form. So you can see that it was important in the electron transport chain, but the ubiquinol also has the function of actually helping reduce lipid peroxidation and acting as an antioxidant. And we know that oxidative stress is also one of those components of aging that can influence cellular damage. So ubiquinol levels tend to decrease with age. So when we're thinking about supporting the mitochondria, we want to ensure that there are the Bs, the CoQ10, the ubiquinol, and we can see that in some tissues, particularly the heart, levels really do decline as we age. Now, interestingly, I was reading a paper after I put these slides together, otherwise I would have put it in just last week, and it was comparing the age range, 20 to 40 years of age to 40 to 60 and then 60 plus. And it was showing that the amount of ubiquinol compared to ubiquinone was higher in the 20 to 40-year-olds. So that's that antioxidant form of CoQ10. Whereas in the 40 to 60-year-olds and then the 60 plus, there was more CoQ10, more ubiquinone and less ubiquinol. And they were suggesting that is due to the buildup of free radicals and oxidative stress as we age. But we also know that the enzymes needed to convert, even if people don't have the genetic variation NQO1, start to slow down. Also, as we age, often there might be more stress. exposure to environmental toxins. These chemicals and toxins build up in the system, and they can influence this as well. So we talked about evidence-based strategies that can support the mitochondria and healthy aging. And in 2023, I started a healthy aging, the BioAge study, along with my co-investigator, who was an exercise physiologist. And if you want to support the mitochondria, believe me, exercise needs to be an absolute necessity. Of course, if someone's got chronic fatigue, when we're talking about some of these mitochondrial dysfunctions, if someone is really struggling, we need to start at a very basic level. Maybe it is, just walking 10 meters, if they can do that. Maybe it's different, it's other approaches if they really do have that extreme fatigue, but movement needs to be there. They need to build muscle because you can actually get more mitochondria and make more energy. So when we started this study, my plan was to put together a protocol that would last for 3 months and look at biological age at the beginning and then after 3 months. But we decided at the 3-month point or just before it to continue on and do 6 months as well. So this was an intervention that included nutrition advice, supplements, and lifestyle to alter DNA methylation. So the way that we do biological age testing at this point, you can do blood markers, but also through methylation. So although mitochondria is considered one of the hallmarks of aging, we don't yet have a mitochondrial test that has robustly and been validated linking with biological age. Whereas with methylation, these epigenetic patterns on the DNA, we have about a decade of research understanding how changes in these epigenetic patterns are linked with either faster or slower aging. So the hypothesis was that nutrition and lifestyle habits can reduce biological age. This was a prospective cohort with men and non-pregnant women. We used the biological age test from True Age, which was an at-home blood spot collection. And then we measured their biological age at the start, after 3 months, and for those that stayed on after 6 months. So with the protocol, it was making sure they had plenty of filtered water, starting the day with a hydrating drink, so not that coffee. We don't want to trigger that cortisol first thing in the morning. Aiming for a minimum of a 12-hour fast, eating organic or spray-free as much as possible, getting most of their carbohydrates from vegetables, legumes, nuts, and seeds, having their last meal approximately 3 hours before bed, even if it's, 2 hours, but in this case, we said 3 hours. I need to probably get back to this myself as I remind myself of the protocol. Avoiding adding sugars, highly processed food, and refined grains. A maximum of 2 coffees per day. And so this doesn't mean that I'm telling people they should drink coffee, but if someone is already drinking coffee, it's a maximum of 2 and before 2 p.m. I get a lot of questions about this one. And if you are thinking about these questions, because I do DNA testing, some people might have a genetic variation in CYP1A2 that affects caffeine metabolism. We weren't doing personalization and genetics in this. This was just an overall protocol for everyone. And of course, if someone knows they've got certain genes and caffeine's not good for them, they definitely wouldn't be drinking. But this is just a general protocol to give guidance of these lifestyle factors. Limiting alcohol to 2 standard drinks. Most of the research is pretty clear that alcohol does not support healthy aging. We have some studies to indicate that red wine may be beneficial as part of a Mediterranean diet for cardiovascular health, but the majority of studies show that alcohol actually has a negative effect on methylation, on oxidative stress, cellular damage. But I have it in here because I wasn't just trying to create a protocol for 3 months. I'm trying to create something that people can stick to lifelong. And the reality is, even though from a molecular cellular level, alcohol may not be good for us, there's also the other side where social interaction is really important, enjoying yourself. And if someone wants to have 1 drink on the odd occasion to celebrate, that might actually be really good for them from a healthy aging perspective, as in socializing, connecting, things like that. So minimizing plastic and drink containers, so reducing things like BPA. So BPA is a hypomethylator. It rips methyl groups off the DNA. It's associated with developmental defects and cancers. That's why it's meant to be taken out of the plastic, but still in some plastics, or there are other chemicals similar, but they definitely influence DNA damage, epigenetics, and mitochondrial dysfunction, and overall reducing that chemical load through trying to use more natural household cleaners, fragrances, skincare, and beauty. So reducing those toxins that we know that can affect the mitochondria, the cellular health. Yes, supporting all of that. When it comes to the diet, it was a whole food diet, high in vegetables, 6 serves of veggies a day. So when it comes to a serve of veggies, sounds a lot, but half a cup of cooked vegetables is a serve. So if you're having half a cup of cooked broccoli, it's not really much. But 6 serves of veggies and relatively high protein. So 1.5 to 2 grams of protein per kilo of body weight. Now, as I mentioned, we had an exercise physiologist who was with us. Exercise was a big part of this study. They had an app that they could, get exercise information from, ranging from if they had injuries and had not exercised all the way through to advanced training. But the intention was that they would actually put on some muscle during this study. So I do want to make it clear, I wouldn't usually suggest that higher protein if someone wasn't doing the strength training and that regular exercise. And the details of the protocol are available. So shout out to Pure Encapsulations, because they did provide the supplements for the first 50 people. When I conjured up this in my mind, I quickly reached out to Joe. Some of you might know Joe Lerberg, and asked him if he would support the study. And Pure did provide supplements for the first 50 people. We had more than that sign up. And then when it came to the 6 months, they had to buy their own supplements. But I did say I would share this information with them. So they've written up the protocol and you can get access to that. I've got a link there for those that actually want more of the details. From a supplement perspective, we had a B complex. So I chose this because the B vitamins, they're not just important for the mitochondria, talking about that NAD, FAD, niacin, riboflavin, but also supporting methylation. Also, most of the patients I work with, you're probably the same, dealing with day-to-day stresses. This supports, clearing out our cortisol, supporting that enzyme COMT. So the B complex was important. Resveratrol. So we have a good decade or so of research with resveratrol, cell culture, animal, human, more so with metabolic health than mitochondria. There is some suggestions around mitochondria, sirtuins, healthy aging, but the reality is the resveratrol research tends to show improvements in lipid markers like cholesterol and blood sugars, a bit similar to berberine. I then had ubiquinol, 100 milligrams twice a day. I'm not sure what your dosages are over there. The product I used was obviously from Pure. In Australia, we tend to have a lot of 150 milligrams or 300 milligrams. Most of the evidence for ubiquinol is in the range of 100 to 300 milligrams, with most of them at 100 to 200. So I chose 200 milligrams here. And the nicotinamide riboside. So if we're thinking about supporting the mitochondria, ubiquinol and things like nicotinamide riboside or NMN are very popular. Now in Australia, NMN, these other NAD precursors to support the mitochondria, to support ATP and energy, are not approved by the TGA, our regulatory body. We only have approval for nicotinamide riboside. So I used that. And it's a relatively low dose. If you know about nicotinamide riboside, the reality is you probably do want closer to 300 milligrams. I did find a study to show that 100 milligrams, there was some evidence in mouse models. We don't have as much research as we do for resveratrol or ubiquinol or CoQ10. We have a lot less for the nicotinamide riboside, but more for nicotinamide riboside than NMN when I was doing the research. But here, getting a product with 300 milligrams was difficult. So we had a particular product here in Australia that had 100 milligrams, and for those using Pure internationally, there was a product with 50 milligrams, and then they just had to double the dose. And then we had our liver GI detox. with wonderful things in it supporting detoxification, sulforaphane, turning on all those nice antioxidant enzymes. And these were the 5 core products that I chose to support the mitochondria, epigenetics, reducing DNA damage, trying to reduce that oxidative stress, supporting metabolic health. But in saying that, if someone was not eating regular small oily fish like sardines, whatever it may be, omega-3s were discussed. We did do vitamin D testing. If someone was low in vitamin D, this was added in, and we had one person, because we did blood tests at the start, that was deficient in iron, so we added that. But these were our 5 core products that everyone was taking. So when it came to the recruitment, we had 60 people. We could have had more, but we capped it at 60. It was there was a lot of interest. However, when it came to actually doing the 3-month test, we only had 41 people do it on time. So we had about another 10 do the test later on, like not within the time frame because things happened. So we had about 50 complete it and 10 we lost. So when it came to the reasons why people didn't complete the test, there were medical contraindications. Actually, we had one lady straight away who it was a pity she signed up, wasn't recruited properly. She actually had rheumatoid arthritis and was taking methotrexate, so she couldn't have the B vitamins every day. Some people withdrew, other people had personal issues, and then there was a couple of people that actually had sample errors as well. So when you collect the blood spot, the dry blood spot for the biological age test, you're not meant to touch the cardboard, but you're waiting for the blood spot, and some people did that, and a few issues with samples and lab errors. So looking at the results, this is just a correlation looking at one of the biological age markers known as pheno-age. Now, you might know pheno-age. It's something that you can do with typical blood biomarkers. So you can use 9 blood biomarkers, CRP, a couple of the red cell markers, liver enzymes. You can put those together, and there is a validated what's called pheno-age. It was first published in 2018 by Levine and also Stephen Horvath, who's a bit of a guru in this place of biological age and epigenetics. So there is a blood biological age test you can do. Some of you might be doing, a lot of longevity clinics use that. But there's also an epigenetic, a methylation pheno-age, where they're using these methylation patterns as sort of surrogates for all of these blood markers. And in this case, I'm just describing one of the tests here, but what we're looking at here in this result is just a comparison between chronological age. So your chronological age is your birthday. We can't change that. So for example, I'm 47, but your pheno-age or your biological age, depending on those methylation epigenetic patterns, could be higher or younger. And just to give you an example, so this is just showing there's a correlation between the chronological age and the biological age, and there should be, otherwise there's a problem with the samples. But to give you an example here, if I just look at the 60-year-olds, so we had, these 60-year-olds in the study, as we go up and we look at 60 over here at the pheno-age, we can actually see that majority of people did come out quite a bit younger when they're looking at the pheno-age. I love the pheno-age personally. I'm not sure if you've done your biological age testing. If anyone has and you want to share your results, you can tell us how much younger you are. You might not want to disclose it if you're older, but I really like the pheno-age. I come out almost 10 years younger, but it's definitely not the case for some of the other biological age tests that are out there. And I think that's an important thing to note when we start doing testing, is that a lot of these are using different algorithms, different methylation patterns, different ways of assessing biological age. So when it comes to the pheno-age, the baseline age of the group, the people that signed up, was 51.3. So actually this is just the 41 people that did the start and the 3 months. And what we found is that there was a 2.3 year reduction in biological age in that 3 months, and that came out significant. One of the most striking results, and this is from a clock that actually was published in Nature in 2024, a newer biological age clock, but this is more to do with cellular damage or DNA damage. And the baseline age, according to this biological age clock, was much higher at 70, but there was a huge reduction of 8.8 years by following that protocol. So the nutrition, the exercise, the lifestyle, and those supplements. And for those who are interested in the paper, this is it, Nature Aging, talking about this damn age clock. So we also then had the 6 months. So we had a group of people decide they want to stay on. And this is with the intrinsic clock. If you happen to have done true age testing or you're looking at true diagnostic testing, one of the tests they have, or it used to be at the start, they've updated their report, was this intrinsic clock. This is one of the original biological age clocks, first published in 2013 and then adapted. This is Stephen Horvath's. So when we did the 3 months, there was not a significant reduction. There wasn't a big difference and it wasn't significant. But after 6 months, there was actually a bigger reduction in biological age, so overall 2.9 years, and that came out significant. So I'm going to run through some of the actual case studies, looking at the results here. This was our oldest participant, so she was in her early 80s, and she only did the 3 months, not the 6 months, but she came out 10 years younger when she started the study. And this is no surprise. She's been working with me, I think, for almost 10 years with her daughter. She's actually really well. She cooks for her daughter. Her daughter's a dentist, an integrative dentist, but she cooks, she exercises, she's going for little runs. She's very healthy. So it was no surprise that she comes out so young. And for those of you that do a lot of functional testing, every year she does a stool test, an oat test, Dutch test. So she's very invested in her health. But she actually came out 5 years younger after doing the 3 months. And I really didn't think that we would see so much of an improvement. And she definitely came out, when it comes to the 10 years younger, she was probably one of the youngest, sort of that 10-year gap compared to really anyone else in the study. The differences for her, because I knew her so well, she was one of my patients, was that she changed her exercise. She used to jog, so she moved to more strength training, reformer Pilates, definitely more protein. If anything, even though she ate really well, she probably had a low protein diet. And then from a supplement perspective, the nicotinamide riboside was new, even though it was low dose. The ubiquinol, she'd had CoQ10 in the past, a long time ago, but not ubiquinol. And the resveratrol was new. But the B vitamin she'd had similar things with the liver detox. So, of course, we can't say exactly what it was, but those slight changes made a big difference for her. And she's still kicking goals and putting on muscle and doing really, really well. And this was a few years ago, these results. So this is me. My first test actually came out older. I think I might have shared it with some of you that are listening. It's come down over time, which is good. But my biggest improvement, and in the 3-month study, was that my Dunedin pace. So we actually have, when you do biological age testing, you get all these different types of biological age assessments because different things have been published. Different scientists, different, whether it's Harvard Uni or this one has brought out Cambridge has brought out a biological age clock they've been working on, and they've associated it with whatever it is, cardiovascular disease, Alzheimer's, skin aging. There's all these different clocks. But the Dunedin pace, this one is not trying to determine a number. It's not saying you're 55 or 45. It's basically saying if you're less than 1, your pace of aging is much slower. And if you've got greater than 1, that's called accelerated aging. And you might have heard of this one, even if you're not doing a lot of testing, because this is the test that a lot of the biohackers do. So Brian Johnson, who's really quite loud in this space, spending millions of dollars on all these, even tried rapamycin and gene therapy and all of these things trying to slow the aging process. When he says he's only aging, 8 months a year rather than 12 months, he's talking about this Dunedin pace. But there was about 3 of us that had really good results around our Dunedin pace. And this is sort of matched with my biological age that has been coming down as well. So I also wanted to share the results from this firefighter. So his intrinsic age, biological age came out at 60, chronological age 65, so about a 5-year difference, 5 year younger. Not a massive change overall in the 3 months and the 6 months. He did get younger initially, particularly in the first 3 months, and his Dunedin pace came down. He was actually one of the few that was over 1. So over 1 means accelerated aging. And he actually joined this study because he'd had a lot of colleagues. He actually retired towards the end of the study, so he was near his retirement as a firefighter. But because of the amount of chemicals he was exposed to, he was really concerned about that. And a lot of his friends that had retired or near retiring had cancer and a lot of issues that they thought may have been linked with a lot of the chemicals that they were using when they're spraying all these fires and things like that. But he definitely had a big improvement in his Dunedin pace. But the reason I wanted to show him is that the exercise physiologist that was helping support this cohort with me, this group of people, suggested a few months in that people should do a DEXA. Now, this was not a standard part of the test. We did bloods, they were optional, but most people did bloods at the start. It was really just doing the biological age to see, is this test worth bringing into clinic? And if the test is reliable, can we do something about it? Which is, the protocol, looking if we can slow biological age. But he did his DEXA. So he did the first one on the 17th of July, 2023. So the study had already started for a few months. He did the 3 and 6 months. But in the time he did that, from July to December, he actually lost 3.5 kilos of fat mass. So a significant change, there, less, almost 20% of that sort of fat mass, but he gained 0.5 kilo of muscle. And the person doing the DEXA said they'd actually never seen someone gain that much muscle and lose that much fat in a short amount of time. Often you can lose weight quickly, you might lose some fat, but you might lose a little bit of muscle. But in this case, he was gaining that muscle. And that's really what this study was about. Not the biological age side of things, but also that body composition. When we're thinking about healthy aging, we want to be fit, we want to be strong, we want to be able to move our bodies. And in addition, when we look at the visceral fat, that adipose tissue, we can see that visceral area came down from 159 centimeters squared to 115, so losing a lot of that belly fat. Another example of one of the case studies, the people that did the 6 months, so she dropped her age quite significantly at the start. Then there was a little bit of a blip at the 6 months. I will say that most people that did the 6 months, even if they still came out younger than when they started the study, the pattern was a lot like this. So in the 6 months, a few things happened. It got close to Christmas. It was December. People were bringing in alcohol. Some people weren't as compliant with the supplements. The resveratrol, whether this made a difference or not, I'm not sure, but the resveratrol extra was out of stock. So there was a couple of people that didn't have that for a little while. But really, the moral of the story is the 6 months, a lot of people kind of relaxed. So it was interesting to see that to get that big shift, we do need to be a little bit stricter with the protocol. So the reality is, if someone needs to really get out of a chronic condition, or they are aging at a faster rate, perhaps sticking to the protocol a bit more tightly. But the reality is, once we get back into life, often some of these things are a little relaxed. So this is her Dunedin pace. Her pace of aging is coming down. So it's showing that she's actually aging at a slower rate now, which is fantastic. And I haven't explained this here. I've just got one more case study before I finish this, but I want to just mention these graphs here that you're seeing with all these biological age markers. The blue line is the median. The black dots are all the people that have done the test. Now, when I say all the people that have done the test, it's not necessarily representing the general population, because the people that do this test are, one, interested in their health. So they're probably taking an interest in their food and their lifestyle. They've got the money to pay for the test. So generally a little bit more affluent, potentially a bit more educated. And we know these people tend to have better quality of life, and ideally may have improved health. And I say that because if we were looking at the general population, or people that didn't have access to this kind of testing, that kind of information, it might be a little bit different. But we can see here the orange dot is her, and her Dunedin pace is excellent. And we saw this with most of the people, their Dunedin pace was coming down, that pace of aging. And the last one, a very similar pattern. We got lots of case studies from the trial showing that her biological age came down, plateaued a little bit, and then her Dunedin pace. So this was someone too that had a higher accelerated aging at the start. It came down. Interestingly, if I just go back, she actually wonders if this was a little bit falsely elevated because she had had COVID before it. And one thing I definitely learned in this study is that COVID definitely pushes the biological age up very quickly. So the testing company tells you that if someone has been sick, so they've had an infection or an injury, something that potentially has influenced their health, wait 2 weeks from the time you are better. But what I learned is that some of those people that did get COVID during the study, their biological age went up, even though they felt better. We actually had some other markers and symptom questionnaires and things like that. Even though they improved, it looked like having that infection really did accelerate aging, push their biological age up. So I'm now telling people if they're coming into the clinic or if we're doing this kind of testing and there is something that I think might have affected those epigenetic patterns, they're pretty dynamic. I now know how quickly they can change, but definitely viruses and injuries and things like that, it's wait at least 4 weeks after you feel better to try to get back to your baseline so that we're not actually getting a result that's influenced by that sort of transient change. So she had had COVID, and even though she thought she was better, when we started learning this during the study, we think this may not have been that high. And you can see here too with that accelerated aging over 1. So these are the supplements, listing them here: the B complex, ubiquinol, resveratrol, liver GI, mitochondrial ATP. I don't think in the Philippines you can access this. We can't access this one in Australia. I used a different nicotinamide riboside with the 100 milligrams, as I said. And the protocol with the 6 serves of veggies, all the food, the lifestyle. So talking about the exercise, we recommended 7 to 9 hours of sleep, quality sleep most nights. We had fortnightly group sessions. We taught people about tracking, or even if they weren't tracking, with a Whoop or an Aura ring, just making a note of how they felt in the morning, changing their habits so they weren't on the screen, things like that. And as I said, this has all been shared with Pure if you are interested in looking at it, adapting it, or taking some of that and using it with your clients and patients. So in summary, in the Philippines, we know that lifespan is increasing like it is across the globe, but the healthy years, the health span is declining. And this is what we're seeing, as I said, when we look at data. I haven't shown you the global data. There was a paper published at the end of last year, 2024, in JAMA, showing the global data, and that health gap, those years of living with a chronic illness or a disability, is increasing for most countries across the globe. So the focus must be on shifting, adding more healthy years, slowing down that pace of aging, not just living longer. So when it comes to the mitochondria, mitochondrial dysfunction is one of the major hallmarks of aging. This can impact our energy. People feel it. They're fatigued, they're tired, they feel heavy, their muscles aren't working. They get a buildup of oxidative stress, and oxidative stress, like inflammation, is a driver for all chronic health conditions and age-related conditions. When it comes to the nutrients and cellular support, we definitely want to be thinking about our B vitamins for the mitochondria, ubiquinol, but also the polyphenols. So the resveratrol and some of the things in the liver GI are polyphenols, but also the diet. We need to think, even though I mentioned a lot about the supplements, I don't think that the supplements would have the same effect if people were not making these foundational changes. So having those 6 serves of vegetables, 2 serves of greens, 2 serves of cruciferous, and 2 serves of coloured, those coloured, the purples, the reds, the oranges, all these beautiful polyphenols that we know can support the mitochondria, reducing the DNA damage in the mitochondria as well as our cells, helping reduce that oxidative stress from the mitochondria, as well as other nutrients to fuel both mitochondrial health and reduce those free radicals. So aside from these particular supplements, you know, the nutrition and the lifestyle interventions are important as well. So if we're wanting to increase our mitochondria and increase our energy, we want to be exercising, we want to build more muscle. So as we build more muscle, as we are fueling our body with ATP, we can then start to, build more mitochondria or have more mitochondria replicate in other cells as well. But the exercise is really important. We want to have a whole food diet, rich in plants and enough protein to support that growth of muscle and lifestyle modifications, including exercise, sleep, and mindfulness. So I didn't mention it, but 5 to 10 minutes of mindfulness was part of the protocol each day. They had an app. So the exercise physiologist that supported me had his own app, and we put my protocol in there and they could tick off, I've had my 6 serves of veggies, I've had my supplements, I've done my 5 minutes of mindfulness. And in the app, he obviously had all the videos for exercise, but also some suggested meditations, or we suggested other apps as well. I will say though, for those of you who don't have these kind of resources, I generally don't use an app like that with my patients. Only about 50% of the people use the app. And of those 50%, only about half probably used it properly. I thought it would be a game changer. I thought every day, because I did the study as well, and I was really good for the first 3 months, but I did not do the 6-month test. So I actually had some international travel. And sadly, those plane flights, there's also transit epigenetic changes, all that radiation, different time zones. So I didn't do the 6-month one. I knew that the results probably wouldn't have been so good. So yes, getting back to here, whoops. Excuse me, going here. So we've got our whole food diet, our lifestyle, the app is what I was talking about. And yes, I didn't use the app as much as I thought I would, but I still had great benefit from the protocol. I think once you start feeling a bit better too, and once you've actually just got something in front of you, even though we have the knowledge as practitioners, you know so much of this, I know so much, but when it's in front of you, you're kind of like, this is what I'm doing. It's a little bit easier. Sometimes we need this to be told ourselves to do these things as well as for our patients. So I thank you for your time. I look forward to your questions.